Good morning, students. 8th Standard Chemistry, Chapter number 9, Carbon and its Compound. So, in this chapter, today we are going to learn carbon dioxide, how it is prepared, what are the physical and chemical properties of carbon dioxide, and what are the uses of carbon dioxide. So, this is the topic today we are going to learn. So, before that, I want to have a recap of our previous class. So, in this chapter, we have first learned about carbon and some special properties of carbon like catenation, multiple bonding and allotropes. In that we have studied two kind of allotropes. One is crystalline form of allotrope, another one is amorphous form of allotropes. So next in this class today we are going to learn about the compounds of carbon. So in that first we are going to learn about carbon dioxide, which is a very important gas for the existence of life on the earth. Why it is very important for the existence of life on the earth? Because we all need food. So we depend on plants. So plant prepare its own food with the help of the process photosynthesis. So for that carbon dioxide is very essential. So that's why I told you carbon dioxide is very important for the existence of life on the earth. Okay. So now let us discuss about carbon dioxide. Carbon dioxide is composed of one carbon atom and two oxygen atoms. The formula of carbon dioxide is CO2. So it occurs in free state in air and it constitutes 0.03 percentage by volume of air. So air contains 0.03 percentage of carbon dioxide. So carbon dioxide is in free state in the air. So carbon dioxide also occurs in combined form as minerals. For example, limestone, calcium carbonate, which is a mineral of calcium. So mineral contains carbon dioxide in the form of carbonate salts. So all the carbonate salts contains carbon dioxide. Therefore carbon occurs in free state as well as in the combined state. Yes, children? Okay, so now we learn about the preparation of carbon dioxide. How carbon dioxide is prepared. In various ways we can able to prepare carbon dioxide. So first one, heating metal carbonates and bicarbonates. So from carbonates and bicarbonates we can able to get carbon dioxide. So these processes are called decomposition reaction. So calcium carbonate decomposes and it produces calcium oxide and carbon dioxide. Zinc carbonate decomposes and split up into zinc oxide and carbon dioxide. And a bicarbonate, sodium bicarbonate also decomposes, produces sodium carbonate, water and carbon dioxide. So in these ways we can able to prepare carbon dioxide. And burning carbon. So carbon burns in the presence of oxygen and produces carbon dioxide. And it's a burning process, therefore it liberates heat. So in these two ways we can able to prepare carbon dioxide. And now let us see the laboratory preparation of carbon dioxide. How carbon dioxide is prepared in the laboratory. So by the reaction of calcium carbonate with the help of hydrochloric acid. So if we add hydrochloric acid and calcium carbonate, it produces calcium chloride, carbon dioxide and water. So this is how carbon dioxide is prepared in the laboratory. So let us discuss the procedure. So first we need to take a round bottomed flask and there is a thistle funnel. Through this thistle funnel we are going to introduce dilute hydrochloric acid. So in this round bottomed flask we have taken marble chips. It is nothing but calcium carbonate is taken and water is also added, and after the addition of dilute hydrochloric acid it reacts with marble chips, that is calcium carbonate, then it liberates carbon dioxide gas. So carbon dioxide gas, it's get collected in the delivery tube. It is get collected in the gas jar with the help of the delivery tube. Okay. So it is collected by the upward displacement of air. That means carbon dioxide is heavier than air. Therefore, carbon dioxide displaces air. So carbon dioxide is collected by the upward displacement of air. So this is how carbon dioxide is prepared in the laboratory. Now let us watch the video to make it clear.
Carbon dioxide.
So how to prepare carbon dioxide in the laboratory. So let us learn this. So first we need to take a round bottomed flask. So in that we need to put some marble chips. It is nothing but calcium carbonate. And there is a pistol funnel is inserted in the round bottomed flask. And through this pistol funnel hydrochloric acid is introduced. And the marble chips and hydrochloric acid reacts and they produces carbon dioxide gas. And the carbon dioxide gas is collected in the gas jar with the help of a delivery tube by the upward displacement of air. Okay, so this is how carbon dioxide is collected. Now let us check the properties of the gas collected in the gas jar. So it is colorless and it has a faint odor. So very faint odor in the sense they don't have a odor. So very faint odor. And if you put a lighted splinter, it put off the fire. So from this we conclude that the gas is a carbon dioxide gas. So that's why it extinguishes the fire. So now let us learn the equation. So calcium carbonate CaCO3 plus hydrochloric acid HCl produces calcium chloride, water and carbon dioxide. Calcium chloride CaCl2, water H2O and carbon dioxide CO2. So carbon dioxide is prepared in the laboratory. Okay children? Okay, so now let us discuss the properties of carbon dioxide. First, we'll learn physical properties of carbon dioxide. So already we know that it is a colorless gas, odorless gas. Odorless means they don't have a smell. And it is fairly soluble in water. That means they are soluble in water. And carbon dioxide gas is heavier than air. So that's why it is used in fire extinguishers as it is neither combustible nor a supporter of combustion. So carbon dioxide gas is neither combustible nor a supporter of combustion. That means carbon dioxide do not burn. So the carbon dioxide is a non-combustible substance and it won't support combustion. So that's why it is used in fire extinguishers. So three reasons. One, carbon dioxide is heavier than air and it is not a combustible substance and it won't support combustion. So for these three reasons, carbon dioxide is used in fire extinguishers. And while cooling the carbon dioxide gas nearly minus 70 degrees Celsius, it forms a white solid which is called as dry ice. It also sublimes. On heating, it sublimes and it produces the gaseous carbon dioxide. Okay, children. So these are the physical properties of carbon dioxide. Now let us learn the chemical properties of carbon dioxide. So it is a linear covalent compound of carbon and oxygen. You know that carbon dioxide contains carbon and oxygen. Carbon and oxygen shares their electrons and forms covalent bond. So the carbon and oxygen forms covalent bond and they are in a straight line. So that's why carbon dioxide is a linear compound. So linear covalent compound. It is an acidic gas. Therefore, it turns the blue litmus paper into red. Okay. Now let us learn the reactions of carbon dioxide with different chemicals. First, we will go with hydroxides and oxides. So carbon dioxide reacts with hydroxides. First one, calcium hydroxide, which is nothing but lime water. So calcium hydroxide reacts with carbon dioxide and it produces calcium carbonate. So calcium carbonate is a precipitate. So it is insoluble in water. So that's why we say it is a precipitate. So thus the lime water turns milky when we pass carbon dioxide. Okay children. So next with sodium hydroxide. carbon dioxide reacts with sodium hydroxide and it produces sodium carbonate, which is a salt, and it also liberates water. So that's why the reaction is known as neutralization reaction, because an acidic gas reacts with a base and produces salt and water. So it is a neutralization reaction. Third one with potassium oxide. Carbon dioxide reacts with potassium oxide and produces potassium carbonates. Okay. So carbon dioxide with hydroxides and oxides produces carbonates. Okay. Next reaction with carbonates. First one with calcium carbonate. So calcium carbonate reacts with carbon dioxide. Excess amount of carbon dioxide reacts with calcium carbonate and they produces calcium bicarbonate. So it is soluble in water. And with sodium carbonate, so carbon dioxide reacts with sodium carbonate and produces sodium bicarbonate. Okay children, so carbon dioxide reacts with carbonates and produces its bicarbonates. Okay. So next, carbon dioxide with water. So carbon dioxide dissolves in water and produces weak acid, carbonic acid. H2CO3 is called carbonic acid. Carbon dioxide always dissolves in water. They produces a weak acid, carbonic acid. Reaction with metals. Carbon dioxide reacts with metals and produces metal oxide and carbon. For example, magnesium is a metal. So carbon dioxide reacts with magnesium, that means burns with magnesium and produces magnesium oxide, and carbon is left out as a residue. Okay children, therefore carbon dioxide reacts with metals and produces metal oxide. So these are the reactions of carbon dioxide with different chemical substances. So let us pass on to the uses of carbon dioxide. What are the uses of carbon dioxide? First one, we discuss about dry ice. I told you, so under very low temperature, nearly around minus 70 degrees Celsius, carbon dioxide is turned into dry ice. Solid carbon dioxide is also known as dry ice, which is used as a refrigerant. So that is a cooling agent. So dry ice carbon dioxide, solid carbon dioxide is used as a cooling agent. So it keeps the atmospheric conditions cold and it inert. That means it helps in killing the undesirable microbes. So you can able to see the packets in the food items and also in some packaging materials. So they'll have this package. This is nothing but dry ice. So which is kept in the packages in order to make the condition cold and to avoid the undesirable microbes. So dry ice is used as a refrigerant, that is a cooling agent, coolant. Next one. So soft drinks. So usually we have soft drinks, aerated drinks. It is also called as aerated drinks. That means carbon dioxide is dissolved in water. So when you open a soft drink, we can able to hear a fizz sound. Yes. The reason is carbon dioxide gas is liberated. Okay children. So carbon dioxide is dissolved in water and produces carbonic acid. So that's why we have a still taste in our tongue. Okay, and we can also hear a fizzy sound due to the liberation of carbon dioxide. Okay, and third one, carbon dioxide, especially dry carbon dioxide, which is used in fire extinguishers. Already I told you the reasons why. Because carbon dioxide is heavier than air. So when a combustible material burns, if we apply carbon dioxide, it forms a layer over the combustible material. Therefore, it won't allow the air. So the fire get extinguished because the combustible material won't get the air because of the layer of carbon dioxide which is heavier than air. So the layer of carbon dioxide won't allow the air inside and it won't reach the combustible material. So it cut off the supply of air, that means oxygen. So this is how the carbon dioxide extinguishes the fire. We have different kind of extinguishers: carbon dioxide fire extinguisher, soda acid fire extinguishers, etc. etc. Soda acid fire extinguisher is nothing but it contains two chemicals, and when we open the knob, at the time the two chemicals will mix together and produces carbon dioxide. So look at this picture. So it contains two chemicals, one is sulfuric acid, another one is sodium carbonate. So when we open the knob, the two chemicals get mixed and it liberates carbon dioxide. So through this nozzle we can able to get the carbon dioxide. So that it forms a layer on the combustible material and it won't allow the air, so that it extinguishes the fire. Okay children. So the next one is an important one. So the combination of oxygen and carbon dioxide. So 95% of oxygen and 5% of carbon dioxide forms carbogen. So this mixture is called as carbogen, which is used for artificial respiration, when especially in the case of carbon monoxide poisoning and also for the pneumonia patients. Okay, so this is a mixture which is called carbogen. It contains 95 to 90% of oxygen and 5 to 10% of carbon dioxide. So this mixture is used for artificial respiration. So for pneumonia patients, they can't able to breathe naturally, therefore they need to supply oxygen artificially. So for that, the carbogen mixture is used. Okay, children. The last one, carbon dioxide, is used in the manufacture of various kinds of carbon compounds. So to prepare the carbon compounds, carbon dioxide is also one of the reactant. For example, washing soda, baking soda and urea. So washing soda is nothing but sodium carbonate. So it is prepared with the help of carbon dioxide. It is used for washing purpose, and baking soda is used in food industry. It is nothing but sodium hydrogen carbonate. And urea, which is used as a fertilizer. So it is also prepared with the help of carbon dioxide. So carbon dioxide is used in the manufacture of carbon compounds. Okay children. So that's about the uses of carbon dioxide. So now I am going to summarize the today's topic. So whatever we have discussed now. So now we have learnt about carbon dioxide. How it is prepared? It is prepared in the laboratory by the reaction of calcium carbonate with hydrochloric acid. And we learned the properties of carbon dioxide. It is colorless, odorless, it is soluble in water, and it is heavier than air. And we learned the chemical properties of carbon dioxide. That means it reacts with hydroxides, oxides. So when it reacts with hydroxide and oxides, it produces carbonates. When it reacts with metals, it produces metal oxides. Yes. And the last topic we learned about uses of carbon dioxide. So it is used as a refrigerant. Yes, it is used as a cooling agent, coolant. And it is used in fire extinguisher because it is heavier than air and it is not a combustible substance and it is not a supporter of combustion. So that's why it is used in fire extinguishers. And carbogen, a mixture of carbon and oxygen, which is used for artificial respiration. And carbon dioxide is used in the manufacture of various carbon compounds. So today we have learnt about carbon dioxide, an important compound of carbon which forms the basis of life. So it is very important for the existence of life on the earth. Okay children? Thank you children. Thank you so much.